guys, let's do an actual electric fields problem. A point particle of charge Q1 equals 4.4 times 10 to the minus 6 coulombs is placed on the x-axis at x is equal to minus 5 centimeters. A second particle of charge Q2 is placed on the x-axis at x equals to positive 30 centimeters. The electric field at the origin is 0. Determine the charge Q2. Okay, so as with any problem, I want to start by drawing a picture. Now the picture for this problem is going to be a number line, specifically on the x-axis. So let's start off with that. Now I know that on the left side of 0, I have to go to at least minus 5, and on the right side of 0, I have to go to at least positive 30. Okay, so here's going to be my number line. Okay, so let this be minus 5, so that would, and I'm going to go by 5s. So minus 5, 0, 5, 10, 15, 20, 25, 30. Okay, so we can go one more there. So here's my x-axis. This is going to be x is equal to 0. So here's minus 5, positive 5. So I'm going to go ahead and number these spots. Okay, so here's my 0. I know that one charge, Q1, is placed at minus 5 centimeters. So Q1 is right there. Now, according to this, Q1 is positive. Okay, so I know that at point 0, the electric field is 0, so we'll take care of that in a moment. And I know that Q2 is placed at positive 30. Now, there's two things I don't know about Q2. I don't know the sign of the charge, and I don't know its magnitude. But I can figure those things out very easily. The first thing I'm going to start off with determining is the sign of Q2. Okay, so I'm going to take this part of our number line and draw it a little bit bigger here, just so that you can see what I'm going to be doing. Okay, at x is equal to 0, we're told that the electric field is 0. So that we know electric field is given by the symbol epsilon. So epsilon 0 is equal to 0. Now, I know that for positive charges, the electric field vectors go outwards. Okay, so the electric field vectors look like this, outward in all directions, which means that at point x is equal to 0, the electric field due to charge 1 is going towards the right. Okay, so that's the electric field due to 1. Now, if the electric field at x is equal to 0 is 0, that means there has to be something going in this direction to counteract it. Okay, so it has to be going something like this. E2 has to be counteracting it. Now, if E2 has this kind of behavior, that already tells us that from here, the electric field has to be going out. It can't be going inward. Therefore, we can already establish that Q2 must be a positive charge as well. Now, the beautiful thing about the symmetry in this problem is that we already know that Q2 must be positive, and since the net electric field at point 0 is 0, that means that these two must be equal in magnitude and opposite in direction. So we can say epsilon 1 equals epsilon 2. Now the expression for electric field is kq over r squared. So for epsilon 1, it's going to be kq1 over r1 squared. For epsilon 2, kq2 over r2 squared. So our k's cancel out, so there's one simplification already gone. R1 and R2, what do those mean? Okay, so electric fields diminish as you get further away from the source. So R1, as R gets bigger, this whole number gets smaller, right? So R1 is going to be the distance between Q1 and the point of interest, which is x is equal to 0. And R2 is going to be the distance between Q2 and x is equal to 0. And so based on the number line, we can see that R2 is going to be 30 and R1 is going to be 5. Now, it doesn't matter that it's in the negative or positive direction because either way, we're squaring the number, okay? So we're looking for the charge Q2, so let's isolate for Q2. We're going to multiply both sides of this expression by R2 squared. Okay, so Q2 equals, now if I do R2 squared over R1 squared, I can simply write that as R2 over R1 all squared, because I know that that squared gets simplified into going into both terms. Okay, so Q2 is R2 over R1 squared times Q1. So plug in your values. So Q2, I'm just going to switch slides here. Q2 is equal to R2 Now, I've gone ahead and written it in meters. You actually don't have to write it in meters because at this point, it's a ratio of the distances. And if you notice, the meters is going to cancel out with the meters. If you did 3 over, 0.5, it's going to come out to be the same, or 30 over 5, it'll be the same value. The reason I converted it is because generally speaking in physics, we do convert it, so I'm just keeping that habit. But just recognize that it doesn't matter if you put in centimeters in this particular case. Okay, so here's our expression. We're going to crunch those numbers. When you do, you should get Q2 to be 1.584 times 10 to the minus 4 coulombs. Okay, and that's it, guys, for this video. I hope you enjoyed it. And it is positive. I don't have to put the positive in front, but hey, I'll put it there anyways. Guys, if you enjoyed the video, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me. I post every weekday at 12 noon. So stay tuned tomorrow for video 156, Electric Fields 2. Alright guys, that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button so I know what I'm doing makes sense to you guys. And you know how you can stay tuned for my latest videos? By subscribing to Physics in the Flesh. I post every weekday at 12 noon, and this way you guys can always be the first to know when I post a new video. As always, guys, thank you so much for watching. If you missed any of my earlier videos, be sure to click over there on the right. You can click and watch those videos on your screen right now. Anyways, guys, Physics in the Flesh out. Whoop, whoop. Holy crap, my nose looks big on camera. I gotta find a new angle.